Hello Year 7. Today we're going to do a revision lesson. We're going to be revising 3 topics: algebra, sets and Venn diagrams, and numbers. All the material of the lesson will be available under lesson content on OneNote. There are 2 tabs here. On the left you can see one is this whole presentation with the video, and the other is just the exercises that I'll be asking you to do during them. So if you have problem accessing the exercises or you can't see them properly on the video, that's fine. Just go to this second exercises tab. It will all be there. The solutions are all going to be in the other tab, or I'll show them to you on the video. Okay, so the first topic, algebra. Pretty broad topic, but this is a topic we've done fairly recently, so we're going to be galloping through fairly quickly with a minimum of explanation, as this is just a revision class. Okay, so collecting like terms. So we can gather together terms that are the same, have the same number of unknowns in them. So 5a and 3a we can gather together into 8a. Minus 7b plus 3b, that will become minus 4b. And 2c minus c is just plus c. Okay, right, multiplying expressions. We can 3t, I remind you, is 3 times t, and 5t is 5 times t. So if we're multiplying them together, we group them together. 5 times t times t times t is equal to 15t squared. Remember, this index squared means t times t. Okay, next one. That would be x times 3 times x. So you can see that's going to be 3x cubed. Next one. We've got to be careful here because we've got a plus in the middle of it, so we do the multiplication separately. So we've got 5s times 7t, that is going to be 35st, plus 6ts. Now a little bit of a trick, we've changed the order, but it doesn't matter because numbers we can multiply in any order. So that would become 35st, leaving that one the same, plus 6st. So that would simplify to 41st. Okay, next one, bringing in some negative numbers here. So it's minus 4, that's all that is, times x times 5 times x. So you can see that's going to be minus 20x squared. Okay, next one. M times everything in the bracket, that's going to be minus 8m squared plus 6m. We can't simplify this anymore because we can't combine terms. We can't combine m squared with m. We have to leave them separate. Okay, so expanding brackets. When we expand brackets, we take the number outside the bracket and we multiply it by both numbers inside the bracket, taking into account the sign in front of it. So this will become 3y plus 3 times 3, or 3y plus 9. Okay, so doing the same thing here, minus 2x times 6 is minus 12x. Minus 2x times minus x, that would be plus 2x squared. Can we simplify that? No, we can't. Okay, next one. We've got lots of brackets to expand. So we're going to go 3x plus 15 minus, so it's minus 2x, so it's minus 2x. And here we have a minus times a minus, so that would become plus 6. This is easy to get caught out. So this now will simplify to 3x minus 2x, that just becomes x plus 21. Okay, this is a hard example involving other terms, x squared terms and so on, but let's expand this. So that's 6x squared minus 6x. That's the first bracket. So we've got minus 3x times 4x, so that will become minus 12x squared minus 3x times plus 4. That's minus 12x. Can we simplify this? Yes, we can. We've got two x squared terms and two x terms. So that will become minus 6x squared. 6x squared minus 12x squared. And then we've got minus 6x and minus 12. That will become minus 18x. And we're done. Okay, so so far we've been just simplifying expressions. We haven't actually been finding the value of the unknowns. But now we're going to start to do that in solving equations. Equations are a balance of two expressions. Each side of the equal sign is an expression. So what we can do whatever we like to an equation as long as we do it to both sides, pretty much. So in this case, we're going to divide both sides by 3. Divided by 3, divide by 3 to give us y equals 4. So it's just a one-step solution. Next one, we need to get rid of the minus 3 on the right-hand side. So we're going to add 3 to both sides. We're going to have 6 equals t. Now, I've deliberately written it kind of in reverse. Normally, this is the same. So 6 equals t is the same as t equals 6. They're the same thing. It doesn't matter whether it's left to right, okay, or right to left. Getting more complicated, you can build up these number of steps that you need to do. So here, I'm going to minus 6 from both sides as the first step. That gives me 2x equals 6. And then I'm going to divide by 2 both sides again, which gives me x equals 3. And we can check, whenever we do these, we can check the value we arrive at for x works in the equation above. So 2 times 3 is 6, plus 6 is 12. Yeah, so we're happy that's the right answer. Here, involving a bracket, so we're going to expand. So it's 3x plus 6, expanding that bracket, equals 8. And then the next step is we're going to take away 6 from each side to give us 3x equals 2. Yep, so therefore x, and then we're going to divide by 3, x equals 2 over 3. So with these equations, you don't always get a nice round number. You can get a fraction or even a decimal, okay? Right, so the next topic we covered this term was substitution. So, oh, sorry, at the end of last term. So if we're given an expression, all we need to do is rewrite the expression with the values in and then solve it. So here we're not supposed to be using a calculator, so we'd have 4, a is 4, so 4 squared minus 5. Don't forget that c is minus 2, so we put some brackets in, plus 3. B is 1 minus 2. Okay, so what have we got? So 16 squared, 16, that would be 16 plus 10, because minus times a minus is a plus. So, and then plus, expanding, working out what's inside this bracket first, it's 3. Okay, so 1 minus 2 is 3. So that goes to that, and then so that becomes 26 plus, so the answer there is that expression evaluates to 35. Okay, hopefully I've not made a mistake there, but you get the idea. Okay, last thing on algebra, we can use algebra, we're starting to use it to problem solve, so you can get some wordy kind of questions. Here we're told that the perimeter of this triangle is equal to 10. We're not worrying about the units. So what is the perimeter? So we know the perimeter is 10, so we're going to write 10 equals the perimeter is the sum of all the sides. So it will be x minus 1 plus 2x plus 2 plus 3 minus x. So that becomes 10 equals, let's do all the x's first. So that would be x, 3x, that's equal to 2x. That's 3x minus x, yep. And then on the minus 1 plus 4. Okay, Now we can solve this in the normal way. We need to minus 4 from both sides. And we're now at 6 equals 2x. 3 equals x divided by 3. Divided by 3. And that's the same as x equals 3. That solves for x, and then we can write down the various sides. So the sides there will be 2. The side here will be 2x plus 2. So that will be 8. Okay, and here, funny enough, I've put a triangle with a 0 side, but you get the idea. That would be the result of that perimeter. Okay. Okay, so moving on from here, so we're doing the algebra revision exercises. I'm going to zoom in on it. Hopefully you'll be able to see it properly. Rid of that. Hopefully you'll be able to see it properly. I want you to pause now and do the exercise. If you can't see it properly, you go to OneNote, you will find this exercise there. So if you pause that and then resume when you've finished. I want you to spend about up to 10 minutes on this. Don't get bogged down. Come back in about 10 minutes. Okay, so hopefully you've had a good go at that. Here are the answers to the algebra revision exercise. Okay, just check off against what you've done, and if you made a mistake, if you can immediately see what you've done, that's fine. Just have a look at that. Okay, so the next revision topic is sets and Venn diagrams. Okay. Okay, so I've shown you a Venn diagram here. Now A is the round, is everything inside on the left, and B is everything inside on the right. So what is A in terms of what numbers are in A? So using set notation, remember the squiggly bracket we talked about. So everything in A would be 1, 3, 5, 7, 9. Order doesn't matter, but it's neater to write them in order. Okay, so B equally would be 3, 6, 9, 12, 15, 18. Okay, so moving on. A union with B, this upside down is like a cup symbol, is union. So it means what's in both A and B. Sorry, what's the combination of A and B? So that would be the union of the two would be the set. So that would be 1, 3, 5, 6, 7, 9, 12, 15, 18. Okay. Now the next thing is the intersection. It's the upside down symbol. That means it's got to be in both of them. So that's a much smaller set. So that is just 3 and 9. Okay. This special symbol here is called the empty set. So it means nothing. There is nothing in the empty set. In a sentence, what does the area in green show? So essentially that's the intersection. That, as I just said, is all the elements that are in both A and B. So both in A and B. Okay. So yeah, both. So if we were to look at the union, that would be in A or B, but the intersection has to be in both. Okay. So shade the area that is described by elements that are in A but not in B. Okay, so that, if I change the color to blue, is going to be, or purple even, is going to be this area. But it won't be, changed again, it won't be the intersection. It's elements that are in A but not in B. Okay, so that would be that area there. We've got a couple of symbols here. We've used U, which is the universal set. We call it the universal set. Okay. Now you can, in some questions, you will see the symbol for the universal set will be not a U, it will be one of these, but they're the same thing. Okay, so moving on. So drawing a Venn diagram to illustrate the sets A equals this lot and B equals this. Okay, so I'm going to draw this really quickly, roughly. So we've got 2 circles, and then we're going to label this one A, this one B, and then don't forget to label the universal set. So first of all, what we want to do is we want to find all the elements that are in both A and B. So a quick look, we can see that 6 and 12 are in both. So we put those in first. We will start in the middle and work out. Okay, so we can see that this intersection is the elements in both. So 6 and 12. And then we write B will be the other elements. So that will be 3 and 9. And then A will be 2, 4, 8, 10. Okay, and we know that the universal set is all the numbers from 1 to 12 inclusive. So all the numbers that are not inside these two are going to be all we have to write on the outside. So that's going to be 1. We've got 2, 3, 4, so 5, 6, 7, 8, 9, 10, 11. That's it. So we're just going to make sure that all the numbers that we've put in add up to 12, because we know that there should be 12. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. So you're going to get worded questions on this kind of thing. So in 7 above, in this diagram above, if a number is picked at random from the universal set, i.e. any of those 12 numbers, what is the chance that it will be in both A and B? Well, that's just saying, well, which numbers are in both A and B? We've got 6 and 12, so we've got 2 possible numbers out of 12 will be our chance, and that simplifies to 1/6. So we've got a 1/6 chance that the number we pick will be in the intersection. Okay, and other kinds of wordy questions. At a wedding, the guests may have ice cream or custard with their dessert. The Venn diagram shows the information. How many guests had custard? Well, we can see that the guest that had custard will be the guest that only had custard there, and also the guest that had both custard and ice cream. So the answer there would be 43. How many guests had ice cream and custard? That would be 9. How many guests went to the wedding? Okay, so we're not told that, but we can imply it from the diagram, because we know that the total number of elements in the universal set here is equal to, if we just have to add all the numbers together, so it'd be 13 plus 51, 64, plus 9, 73, so that would be 107. So all we've done there is added up all the numbers in the different categories. Okay, so another exercise, set and Venn diagrams. Right, I am shrinking this down, so what I'm going to do is rather than making it tiny, it's going to become in 2 parts. Again, this exercise is on OneNote if you need to refer to that. Okay, so pause now and do the first 2. And when you finish those, pause again and do, showing you solutions, and do the next 2 here. Okay. Right, when you're done, we're going to go on to the solutions. Here we are. Here are the solutions. Check what you've done. Hopefully I haven't made any errors. Okay, so if you need to pause, I'm moving on. So the third thing we were going to revise today was numbers. Right, so factors of 12. Remind you, a factor is a number, a whole number that divides into a number. So in this case, the factors of 12 will be 1, 2, 3, 4, 6, and 12. So it's all the numbers that divide into 12. Okay, another example will be factors of 15. So we know that 1 divides into 15, 2 doesn't, so 3, 5, and 15. Okay, what do we mean by multiples? So multiples are just Now 4 is a multiple of 4, 8 is a multiple, 12, 16, etc., etc. Goes on and on forever. Okay, that will be an infinite number of different multiples. Okay, now multiples of 7 between 21 and 40, that would be 21, 28, 35. Okay, right. How do we determine whether a number is, or try and find a factor of a number? We apply the divisibility tests. I don't know whether you remember that, but if for example, what I'm going to do is I'm going to do the divisibility test that we talked about, some of the simpler ones anyway, on this number 95,364. So without actually using a calculator, it's very important. Is this number divisible by 2? We can tell, yes, it is divisible by 2 because it ends in 4. It ends in even, okay, in an even digit. Okay, so yes. Is it divisible by 3? Well, the divisibility test there is we sum up the digits and we see if that's divisible by 3. So 4 plus 6 plus 3, 13, 18, 27. Is 27 divisible by 3? Yes. So that is divisible by 3. Sum of digits divisible by 3. Okay, that's the test. Divisible by 4. To do the divisible by 4, we take the last 2 digits and we see if it's divisible by 4. So 64, is that divisible by 4? Yes, it is. 16 times 4 equals 64. So it's divisible by 4. Divisible by 5. A number is divisible by 5 if it ends in a 0 or a 5. Okay. In this case, it ends in a 4, so it's not divisible by 5. Divisible by 6. In this case, yes, because the test is if it's divisible by 2, which we know it is, and it's divisible by 3. If it's divisible by both 2 and 3, it's divisible by 6. Okay. Last test that we're going to talk about is divisible by 9. It's very similar to the divisibility test by 3, with sum of digits divisible by 9. Okay, div by 9. In this case, we knew that the sum of digits is 27. Is that divisible by 9? Yes, it is. 3 times 9 equals. So we can immediately, without actually doing the calculation, we can just apply the divisibility tests. There are other tests, but they tend to be more complicated for 7, 8, 11, and so on. Okay, so moving on. What are prime numbers? Prime numbers are numbers that are not divisible by any other number, okay, apart from 1. 1 by convention doesn't count, so we start the divisibility list from 2. So there will be 2, 3, 5, 7, 11, 13, 17, 19. And they go on and on and on infinitely, okay? But we define prime numbers as not divisible by any other number. Okay, to remind you, index numbers. So 5 to the power of 3 is equal to 5 times 5 times 5, which is 125. Okay, and 7 squared is 7 times 7, equal to 49. Okay, right. Prime factorization. We use a prime factor tree to work out whether a number has factors. So here we're going to divide that by, let's say, 12, 10. So those are the two factors. Neither of those are prime, so we keep going. That's 3 and 4. So that is a prime. But 4, that goes there, and this goes to 2 and 5. Now we know that 2 is a prime. Let's get rid of that multiply, actually. And 5 is a prime, but 4 is not, so we keep going. So here we can see that the prime factorization, how many 2's have we got? We've got 3. How many 3's? Times 3. How many 5's? So that would be the prime factorization. You could also write this as 2 times 2 times 2 times 3 times 5. Okay, but I prefer to write it with the index. Okay, so this leads on to comparing two numbers. If we've got two numbers and we want to work out the highest common factor. Remind you what a factor is. It's numbers that divide into these numbers. So what we could do is we could list out all the factors of 24 and then find and then list all the factors of 40, and then just by inspection try and find the biggest one. However, the best way of doing it is to write down the prime factorization of each one. So that would be 24. We're going to do 4, 6, 2, 2, 2, 3. So this is equal to 2 to the power of 3 times 3, and 40. Doing the same thing. 10, 2, 2, 2, 5. So that's equal to 2 to the power of 3 times 5. So we found the two prime factorizations, and therefore what we then do is we say, okay, the highest common factor is made up of the product of all the things that are the same in both. So in this case, it's the 2 to the power of 3. So the highest common factor is equal to 2 to the power of 3, which is equal to 8. Okay. The lowest common multiple, how do we find that? Well, we could list them out. We could just say 12, 24, 36, and so on, and do the same for 30, 60, 90, until we find a number that happens to be the same. However, we choose not to do that. The best way of doing it is to do the prime factorization tree again. So that'll be 4, 3, 2, 2. So this is equal to 2 squared times 3. 30 is equal to, what's it going to be? 2 times 3 times 5. Okay, I've not done the tree, but that's what it is. So what we then do is we say, okay, what is the... We then got to say, well, we take the highest powers of each one. So we'd say 2 to the power of 2 is the highest power of 2. 3, 3, so that's fine. It's just 3, and then 5. So the highest power of each prime together, all multiplied together. So the highest common multiple would be here, would be 4 times 3. That would be 12 is equal to 60. Okay. Now you could have got that just by... So if you have difficulty with that, just by listing out the factors. Okay. Now, you will get questions in a wordy form on highest common factor or lowest common multiple. I'm going to give you two examples here. So a carpenter has been given some wooden planks, 12 meters long and 18 meters long. She wants to cut them up so she has equal size planks. So she's got to find the longest length that goes into both 12 and 18. So essentially this is just what is the highest common factor of 12 and 18. So we know that the highest common factor here is going to be 6. So the answer is 6 meters. Okay. Next one. Sophie checks her bike for repairs every 9 days. Susan every 12 days. After how many days do they need to check their bike again? This is a lowest common multiple question where we have to find the lowest common multiple of 9 and 12. Probably easiest to just list them out. 27, 36, and so on. 12, 24, 36. In this case it's easier because the numbers are fairly small. So here we have they'll both check their bikes again after 36 days. So it just becomes a lowest common multiple problem. Okay, so last section, common sequences that you'll see. A sequence is just a whole, list of numbers with a particular rule. So one common list that you'll see is primes, which we've already seen. That's 2, 3, 5, 7, 11, etc. Okay. Rectangular numbers are non-prime. So, for example, 1, all the numbers that are not that, so that 1, 4, 6, etc. Square numbers, well, that's just 1 squared, 2 squared, 3 squared, 4 squared, and so on. So that would be 1, 4, 9, that should be a squared, 9, 16, etc. Okay. Cube numbers, they are just 1 to the power of 3, 2 to the power of 3, 3 to the power of 3. They can get quite big quite quickly. So that would be 1, 8, 27, etc. You get the idea. Arithmetic sequences, where you're adding a constant each time. So an example of an arithmetic sequence might be 3, 6, 9, 12, 15, etc. Okay, that's just an arithmetic sequence. You're just adding a constant value each time. Triangular numbers starts at 1, and then it's 1 plus 2, and then it's 1 plus 2 plus 3, and then 1 plus 2 plus 3 plus 4. The reason why it's triangular is because it's like we got 1, 2, 3, and you're just adding to the triangle as you go. So that will be 1, 3, 6, 10, etc. Okay. And then lastly, there's this special sequence, occurs a lot in nature, called the Fibonacci sequence, which you need to know about. And that the rule for the Fibonacci sequence is it's just each term after the first 2, each term is the sum of the 2 that have gone before. So we've got 2 there, so that's 1 plus 1 is 2. And then the next one will be 2 plus 1, 3. Next one will be 3 plus 2 is 5. Next one will be 8, and so on. That's called the Fibonacci sequence. Okay, so last exercise, we're doing a numbers exercise. There are 8 questions here. Again, I'm shrinking it down, but it's available on OneNote. If you can't see it properly, go to OneNote, pause now. I will continue in a second. Okay, so moving on, here are the solutions to these questions. Again, hopefully I haven't made any mistakes. These are, just check what you've done. Okay, that's it. And then pause there if you need to. And then if you've still got time at the end of the lesson, there are some extension questions. Here are the first 2. Work on those. And then there's another one here. If you do get onto those, I will post the answers, the solutions to those onto OneNote. So you'll need to go to OneNote to find the solutions. Okay, that's it. See you next time.